running? Why are you running?
One of the product releases I've struggled with most of all has been Charlotte, which is my 8-legged robot project. And I really want to get this product out as soon as possible. If you've checked my website, it's like coming February, coming summer, coming September, coming October, coming November. Right now it's coming November. You can pre-order it now on my company's website, dragline.tech. Now, I have 2 designs that I've made, right? I used to call them Mark 1, Mark 2, but now I'm just going to call them Big Charlotte, Little Charlotte. Big Charlotte was the first version. She was made with mostly trial and error, and Little Charlotte was made with some modeling and a lesser degree of trial and error. Now, I'm releasing Charlotte as a locomotion platform, and basically what that means is that it's going to be sold as the motors and mechanisms. That basically means I'm selling this and not this, because this is still suboptimal. But this, you know, once you add your own electronics to it, it can be pretty powerful. Future versions of Charlotte will have their own control systems and other things like sensors. But for now, what I've been focusing on is this mechanical design. But I have to choose, right? Is it going to be Big Charlotte or Little Charlotte? Is it going to be trial and error or mechanical theory? I don't know. So I realized it's time for me to really put these two to the test in a battle of wits, of strength. I'm going to be comparing their metrics by doing empirical observations. I'm going to be testing things like range, okay? That goes along with battery life. We're testing things like speed. We're testing things like the payload capacity. How much force can it take while it's walking? We're testing things like the weight. We're testing things like the size, which is one of the easiest things to test. And finally, I really want to test agility as well. And that is basically going to be, if there's some obstacle in the way of Charlotte, how much is she affected by it? And that's a mechanical thing in this case. Is she designed mechanically such that her passively controlled walking style is sufficient enough to be completely indifferent to any obstacles that are ahead of her? This version of Charlotte I did test outside in the grass, and I predict that it's pretty good at it. Lifts its legs super high. Little Charlotte is little, right? So she doesn't lift her legs as high, and I predict that she's not going to be as good there. But the first thing that we have to do is give these two a fair fight. I think that Big Charlotte is pretty well robustly designed, so she's ready to go. But Little Charlotte needs some minor modifications to make sure that her legs are in tip-top shape so that she can adequately compete with Big C over here. So let's get to making those modifications and do some tests. So the main modification I want to make is essentially in the stability of these legs. First of all, the rigid parts that form sort of the auxiliary joints aside the flexure joint to try to keep it from twisting in unintended directions. These joints don't make great contact with each other. You can see these two rigid parts kind of slide past one another. And that's when I realized I really need to cut down on the clearance between these parts so that they can actually make contact and kind of push against each other so they don't slip. So the geometry really constrains them to be like more like a pin joint. So the first thing that I did was add some more material to these rigid parts so that these parts would kind of rub against each other a little bit more. And other than that, I just needed to robustify the way that these parts are printed so that they're more structurally sound and just give them extra material. Then I also wanted to make sure I actually did the thing I said I was going to do, which is glue all of these parts together. I always said that this leg with rigid and flexible parts needed to be like a single part. So the rigid materials, which basically are the bones of this leg, and the flexible material, which is basically like the ligaments in this leg, I need to glue these together. Once all of that's done, we end up with a much more stable and robust leg than we had before. And you can see a couple things. First of all, the backlash is much decreased, and it's a lot less prone to slipping out of the hip joint, basically like a hip dislocation. That's something that I saw a couple times. but that's no longer a problem. And another thing is you can see that the leg actually lifts higher and does a longer stride now. So that could possibly make Charlotte more agile and make her faster. So I think this now gives little Charlotte a little bit of a fair fight against big Charlotte, which largely had these issues solved already. Well guys, it's a super exciting day for me because today is the day I got a little package in the mail from this video sponsor, PCBWay. So I've showed you guys this board many times. A custom surface mount PCB that includes microcontroller, motor controller, voltage regulator, yada yada yada. But I made a big mistake with this design because I actually wired the motor controller backwards so that the motors are getting the digital supply voltage and not the battery supply voltage. So we redesigned this board, switched the traces around, and now we should have a brand new custom PCB that has all these issues fixed, and it is going to be our test board for Charlotte today. Let's see, very exciting. Looks like they gave me some non-assembled versions. That's interesting. Okay, so if I ever come by surface mounting equipment, I can do that. Had me a little worried there for a second. Hey, would you look at this? Okay, so we've got a couple things to show here. First of all, I've used a purple solder mask. The solder mask is this material that is covering the board, and I've used the purple solder mask because now until the end of October, you can actually get purple solder mask for free, where it's originally a $40 upcharge. So that's huge. Definitely get on that before October ends. But PCBWay also provides turnkey assembly services. So not only did they make this PCB, but they added all of the components I needed to it. Wow, look at this. It is just beautiful. And we can compare it to the original blue version that has the problem. And you can see it's largely the same. A couple things. LED is rotated. Originally, the footprint I had in the editor was incorrect and had the ground labeled on this corner when it's actually on that corner. So I rotated that so the LED should work right out of the box. We should have the issue with the motor driver fixed. You can see the motor driver's in the same position, but the traces will be switched around. You can actually see I have some nice text written on here that labels everything, including a little dragline dynamics right there for my company, Dragline Dynamics. And I'm calling this controller the arc controller because it's in the shape of an arc. So yeah, that is pretty much it. The final thing is that I have access to the SWD programming, and that is going to make things much easier for me. I won't have to do the crazy magnet wire setup where I soldered magnet wire directly to these microcontroller pins. I'm very excited about this board. It is going to make things much easier for me. It is going to be the go-to board for the spray slit eventually, but for this video, we're going to be using it for Charlotte. So the last time I made a bootloader burner, I did it with a QT Py from Adafruit, but I'm pretty sure I could do it with anything, like this Arduino Nano, for instance. So I'm just going to try that. Okay, so I guess it turns out I can't do it with an Arduino Nano. Okay, so we go back to the QT Py. Yep. Must have something to do with the chip architecture, I guess. I don't know. I'm not an expert in that. I don't get it, but that's fine. Okay, so here we have our bootloader burner assembled. So now we're just gonna hook things up. What's hooked up to our board here, we have power, and we have connections to the RST, DIO, and CLK pins for SWD programming. So we just need to hook that up to our bootloader burner, and we should be in business. All right, and here we go. 5, 4, 3, 2, 1. It's done. Okay, I've just written a sketch here that should cycle through the NeoPixel colors. I love this NeoPixel thing because it's just so compact, and it removes the need for me to use any other indicators on any of my devices. So we've got the bootloader uploaded, and this has been a fantastic success. Way better than the last time I did this. Just know, if you are dissatisfied with the microcontroller shapes that are commercially available, or you're disappointed by the fact that there are no other integrations like a motor controller combined with a microcontroller in a nice, neat shape, you can design your own microcontroller with whatever integrations you want and get it made by PCBWay. They are your one-stop shop for prototyping, and they have PCB manufacturing services as well as CNC manufacturing services and 3D printing services. And make sure you click the link in the description below for $5 off PCBWay's amazing services. Get your purple solder mask before the end of October, and let's get back to putting this guy onto Charlotte. All right, so little Charlotte's legs are still drying glue. They'll be done soon. But here we have big Charlotte. So we just slide in the circuit right there. And then we plug in our motors. 1 and 2. And I've uploaded a sketch that will allow Charlotte to just walk forward, basically. So what we have is, as soon as we plug this in, it starts a 10-second countdown. So the light gets brighter and brighter. And after 10 seconds, we start walking forward. What I want to do is see how easy it is to measure Charlotte's speed with this new hardware. Okay, so I have a distance of 1 meter here, drawn on the ground in Expo marker, as you do. We're just going to set Charlotte at one end and see how she does. 8, 9, 10. Here we go. And the problem is she doesn't have any control systems. So she does kind of veer to one side just based on her balance and all that. So I might have to come up with a solution for that. Maybe I think it's just as simple as starting her off right here. Okay, that works better. 3, 2, 1. Okay, so there she reached it. So after reviewing the footage, it looks like Big Charlotte traveled the meter in 27.2 seconds. That makes her speed around 0.036 meters per second. Here we have little Charlotte with the same test, starting in 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. This one curves the opposite way. The legs are kind of bumping into each other too, so I do need to change the design slightly on the legs, but they're much better than they were before. 9, 10, 7, 8, 9, 10. Go. That's nice and steady. Come on. You got this. Done. Okay, cool. Okay, so little Charlotte completed the journey in 14 seconds, which gives her a speed of around 0.07 meters per second. Pretty much double the speed of Big Charlotte while being quite a bit smaller. Gotta get some shots of this thing moving because it just looks too dang good. That nice and supported. Lots of clearance on the ground. Now, there's a lot more tests to do, and even the speed tests that I just did, not like super scientific, right? So I have a lot of plans to be able to compare these in a more robust way. Then there's the question of what factors really matter, because I'm sure there's going to be some things that Big Charlotte is better at, some things that Little Charlotte is better at. You might have noticed Big Charlotte has different motors than Little Charlotte, and that plays a big role in a lot of this stuff as well. So I definitely want to do a cross comparison to control for that, and that's all coming, because you might have noticed the time on this video. You might be saying, it hasn't been that long. Why is this video seem like it's coming to a close? And it's because it is coming to a close. I think I've come out with so many sprawling epics of videos that I feel like I'm putting a little bit more work, because I enjoy it, a little bit more work than I have to, and it takes away from a lot of the other things that I need to do for the company. But I love making videos for you guys. You are gonna hear about that in 1 week. That's right, in 1 week, you guys are getting another video. So this video is shorter, yes, but you don't have to wait as long. You don't have to wait the normal 2 weeks. It's just 1 week and you're gonna get another video. Can you believe it? It's amazing. In that video, we're gonna talk about the re-strategizing, and we're gonna talk about a project that has to do with the re-strategizing, but it's definitely something that's kind of out there. I think it's just one of my crazy ideas. Not only that, but get ready for 1 video a week for the rest of the year. Can you believe it? It's like the R&D series from 2020 is back. We're going every single Friday, video coming out 5 p.m. Eastern until 2026 lands, and then we'll figure something out. I don't know. It's also going to be a non-sponsored video next week, so it's just going to be me and you know, just like the old days. But until then, stay safe, stay amazing, and I'll see you guys in the next one.